And here we are on the lab again, and this is episode 4 of Build Your Own Main Brain. Okay, so last time we talked about the reset circuit and the ICSP circuit. We have a little bit more to talk about on that, but and we talked about the minimum requirements to get your microcontroller in a position to put code into it. So now we have to go through a lot of things in the lab. It's painful. You want to just like write some code and make things light up and have fun, but there's always this leg work that you have to do, like drill and tap offsets so you can mount the two boards together. Or in this instance, we have to download the IDE and the compiler so that we can make a project to put code into the microcontroller. So once we get that, then we can get down into the meat and potatoes of the thing, as my old teacher used to say. And so that's what we'll do in this video. And then we'll go do some more little specific stuff and see how far past that we can get. Okay, so let's go to microchip.com. All right, then we want to go for tools and develop. Okay, MPLab tools. And right here, MPLab IDE. MPLab X is their, I don't know why they added the X, it's extra, I guess, but it used to be just MPLab, and then around, I don't know, version 6 or something, it became MPLab X. But you can download it right here. And you got to choose if you want Windows, Linux, or Mac. And then you just click on it, download, and then you can download that. And then back to develop, and here you go. You got MPLab and then the XC compilers. So you're going to have to get your compiler, and there's 4 compilers, the 8-bit, 16-bit, the DSC compiler, and the 32-bit compiler, which is what we want. So click on that and view downloads. So this is what we got right here. Compiler for Windows, Mac, Linux, and compiler source. I guess I haven't really even looked at that, but you can download it right here just like that. And then you get those going and installed. I don't think it matters which one you install first. Either way, when you install MPLab or when you start it up, after you install it, it'll find the compiler. So I think we're okay. Okay, so that's where you get the IDE called MPLab X. That's Microchip Integrated Development Environment. And then your compiler, XC32 is your compiler for main brain. And so if I assume everybody can download it and install it okay, just use the default values. But if you have trouble or need more information, then you go to the IO board series of videos, and in there we go into a little bit more detail in doing the IDE and stuff. So we don't want to like just keep hitting it every time I do a video series. So once you install the IDE and get the compiler installed, then we're ready to do some more stuff. Okay, so let's take a look at the programmer. So you know what your options are on that. So the older one is the PIC kit 3. All right. And then I have 2 of them actually. And then we have the PIC kit 4 that I'm going to show you. And then this one is the PIC kit 5. They look the same, but they have a different USB port. All right. And then the cheapest way that you can go is with the snap. It's called the snap. Comes in a little plastic package, but it doesn't have a case. And it doesn't have the debugging features and stuff that the PIC kit has. But it's the cheapest route you can go. It's like 25 bucks or 20 bucks, something like that. All right. And then I don't have any, but they have an ICD 3, the 2. I used to have a 2, but it was deprecated long ago. So they have the 3 and maybe the 4. I don't know how far up it goes, but that's in-circuit debugging. It programs and does a lot more debugging stuff. I don't get into that in-circuit debugging stuff too much. If I have LEDs on the board and a scope, I can pretty much debug about any code that I've ever written anyway. So you can always write some kind of code to trap errors or send out a signal to light an LED or send a signal out on a pin to measure with the scope or something. So I don't really mess around with the in-circuit debugging. Maybe once my code gets more complex, maybe I'll need it. I don't know. But right now, I haven't had to do that yet. So now let's go over and take a look at hooking up the IC or the PIC kit 4. Okay, so in this demonstration, I am going to use a PIC kit 4. There's the PIC kit 3, the 4, the 5. There's a snap, and there's some ICD in-circuit development devices, programmers that you can use. This is the PIC kit 4. I think you can get them for around 50 bucks, 50 or 60 bucks. They program almost all the chips. I don't think it can program the DSP chip. I think it can, though. I think it can program almost all the chips. So if you get one of these, you're pretty much set. You just have to verify that it can program the chip that you want to program. All right, so then they come with this ribbon connector here with a little header. And then red is considered pin 1. So you plug that in to the programmer. So that the pin 1 on the programmer is the little triangle. So you do it like that. And then you want to take your end for your device, and the red one is pin 1. It has to go to pin 1 on the ICSP connector, which is the master clear pin. All right. So you just plug that guy in there like that. And on main brain, the pin 1, the red wire always goes next to the reset jumper. And then, so that means pin 6 that's not used, it hangs off the edge of the connector. But you have to reserve space for that on your board. Unless you could change this ribbon cable to a 5-pin and use that. That's up to you. All right, so then the next thing you need is a USB. And so they use all different styles of USB connectors over the years. But this is the one that the PIC kit 4 uses. Same as the older Samsung phones. All right. So then it plugs in on the end here like that. And of course, the USB never plugs in right the first time. So that plugs in there. That powers up the PIC kit. And you don't need to power your microcontroller up at this time, because you can tell in the IDE, you can tell the PIC kit to power your device. All right. However, since main brain has all the other chips on the board that need powered, I'm not going to power the whole board with PIC kit. So we'll just plug the power in here right now. And now we're ready to jump to the IDE and see if it will establish communication. So when you open up your IDE, you'll get something like this, except you won't have anything in here. This is main brain right here. Um, so what you want to do is go File, New Project, go with the default, and you got to select your microcontroller, which is down here, PIC 32MZ. Way down here, 1024, no, 2048, EFH100. All right. Now, the tool you will select, it'll show up. If it's connected, you'll see it. If it don't see it, there could be a problem. All right. And then you did your compiler. So you select your compiler version. And so then you want to select a name. I'll just call it test for right now. And just, you can use, you don't want to, I don't like MCC. So I turn that off. For beginners, I wouldn't worry about that right now. And so you use the project location. I usually do yes, but I have stuff in there right now, so it's going to give me a warning. So just hit finish. All right, so we got our test here. All right, so test is the main, since it's bold, it's the main project at this time. So if you want to provide power with PIC kit 4, then you just come over here and you hit 4, your PIC kit 4, and then you come down here to power and you click this box if you want it. I don't want to do that with a full circuit. You do that, you power your, like, only the chip or a small circuit. That's all you want to do. Okay. So that's how you configure your project. So let's take and copy some code from main brain. So this is our configuration bits. And this is what main brain uses. So we'll copy this here. We'll come over here. And we don't have any source files. So we'll want to create a new source file too. And we'll select C and next. We want to name it. We'll name it main. And then finish. Okay. Then we'll paste our code in here. All right. So now where you get the configuration bits is up here under production and set configuration bits. And then you can set them how you want them. And then you can generate code. And then you copy the code and paste in there. And then you can edit the code later too. All right. So then the only other thing we need is a main function for the C compiler. So it has to return an integer. Call it main. Does it have to be capitalized? I don't think it has to. What do we got here? No, it doesn't. All right. So main doesn't have to pass any references to any variables. And so then we don't want that. We want our brackets, and that's our program right there. All right. So then it should compile. So if we right click on that and we put clean and build. All right, so that's loaded. So then let's see if we're connected to our device, shall we? So if we hit just this hold and reset, that'll go out and look for our device. So you can see the target voltage detected. If you are powering it, it'll say it's powering the device. Found the device. Device revision, device ID, and some memory stuff. All right, so then we can release it from reset. And there it is. So then we can just, these buttons up here are referencing the current project. All right, the main project. So if you want to reference this one, you have to right click and put set as main project. Okay. So right now we're under our test, so we can just hit program, and there you go. We programmed it into the chip. So our chip is connected, and we're able to write code and send the code to the chip. All right. So then I'm going to put this back to how it was, and I will program that back in. All right, there it goes. Takes a little bit longer because there's a lot more code in the main brain code. And it should finish right about now. All right, so there's one more thing you can do. You can come over here and you can hit properties, and you can go back to your PIC kit and program options. All right, and no, that's not it. Tool options. Okay, program speed high. It defaults to low or normal, so you want to put it on high. It will program faster. Okay, so that's pretty much it. Okay, so now we got our IDE set up, we got our compiler set up, we got our PIC kit 4 set up, and we powered up our chip, and we did a reset to check communication between it, and we programmed a little code in there to test it, and we are ready to get serious about getting the microcontroller coded up from the very beginning. So the very first thing the microcontroller does when you turn it on is it loads the configuration bits from the flash memory, all right, from the boot flash. So we have to configure those things, the configuration bits before we write code, because we're going to program that into the microcontroller, and then each time it boots up, it loads those values, and that determines a lot of things that we have to set up our clock, because we have an external clock. So you can do it. It has clock switchover, so you can power it up on the internal. There's 2 internal clocks you can use to power it up. And then once it's powered up and running, you can, and that saves, the idea behind that is it saves power consumption. And so then once you get rolling in your firmware, then you can switch over to a faster or a different clock. And so MainBrain uses an external oscillator for the P oscillator. So I just boot up the code to the external oscillator with the PLL. And so we have a 24, in order to use USB, you have to have a 24 megahertz frequency going in. So it'll run on other frequencies, but you won't have USB functionality. So we have a 24 megahertz oscillator external. It feeds into the P oscillator, and then it's divided down to 8 megahertz inside, and then it goes through a PLL synthesizer, and the code, or the frequency, goes up to, I think, like 460 megahertz inside, and then it gets divided like 2 times for the core clock, and then you have 7, I think it's 7 peripheral clocks that powered or supply a clock to different things like the timers, and the USB has a clock, and just different peripherals has clocks of their own. So we have to set all that up how we want it, and it gets a little bit complicated, but once you muzzle through it and get your baseline setup that you like, then you can just stick with it, and you can use it on different processors and stuff too. Like you can even do it on the DSP with maybe a few register name adjustments. But so that's what we'll check out first. We'll go through the configuration bits and what they do. Okay, so here we are in MP Lab X version 625 here. This is where you design your firmware to put in your microcontroller. You use it to program it as well, and you can debug. Has quite a few tools that you can do. So right here is my main function, my main C file, and it basically configures all the hardware, all the modules, and provides a little bit of debug information like on the LED port, and then it runs the main program loop. And that's about all this does. On the website, under the firmware, there you'll get a much better explanation of all the different parts of the firmware. And so once you get past the header of your file, then you have the configuration bits. Those should be the very next thing that you put in. Now, this is the exact order that the hardware, the microcontroller, loads all these bits in this order. Well, these, at least the blocks, but I'm pretty sure these are the order of the bits as well as how it does it. And and you can't change that. Moving these around does not change the order in which they're loaded. It's set by hardware. You can't change it. So, the reason for that is if a bit down here just happens to change something up here, then it's in the right order so it doesn't cause some kind of hardware lock or some problem. Okay, so the first one we have is the user ID. Now this is a 16-bit register that you can use to program whatever you want in there. So whatever, an ID, revision, serial number, or a combination of any of those or whatever. I use it for my revision. So I use it for hardware revision 1.2.546. And then you'll see that number on the board in Fusion 360. I keep that listed on the board each time I save a new revision. All right, so this is the latest as of making this video. And then second, we have the FM2 or IIEN. So this is the M2 enable for the Ethernet module. So I don't use the Ethernet module in my hardware design, so it's off. If you want to use the Ethernet, then you would want to turn this one on. Okay, and then next we have this one right here, FETHIO, is the I/O mapping of the Ethernet module. So when it's on, it's in the default pin locations. And if you turn it off, then that changes to an alternate configuration that you may need or want to utilize on your PCB. And so I would just say refer to the specific module within the data sheet for that. Like I said, I don't use the Ethernet module in this hardware. And so next we have PGL1WAY. So that is there are permissions or permission groups that certain modules can belong to certain groups. And after you do the initial programming configuration, then if this is set on, then it locks certain permissions for certain modules uh, based on certain groups, and you can't change that unless you erase it and reprogram the device. That's when it's on. If it's off, then you can just program it however many times you want. It doesn't matter. All right. Now the next one, the PMDL1WAY, it allows you to turn off the clock or disable the clock for certain modules. If you're not using them, like maybe the Ethernet, I'm not using it, I can turn that clock off, and it won't be able to be enabled unless it's reprogrammed. So your firmware couldn't re-enable it intentionally or accidentally when that's turned on. With it turned off, it doesn't matter. Just everything is just normal like that. All right. And the IOL1WAY, that is, so there's PPS pins, which are programmable. So you can change where certain IO pins for certain modules are located. You can move them to different parts of the chip. Not every single pin, but there are some pins. And there are a few peripherals that don't have any pins dedicated on the chip, especially on the 100 pin package. I believe the 144 pin has everything. But even then, maybe, I'm not sure, but maybe it has some too. But the 100 package I use here, there's a couple of modules that have no pins coming in or going out of it. So you have to use the PPS mechanism to program some IO pins for your module. And so that's so that if you don't use the module, you have the IO available, the default IO. But if you want to use the module, then you have to lose a few pins off your IO to utilize that module. So this IOL1WAY register, when it's on and you do your initial configuration, your programming, then your firmware cannot change any of those pins on the fly. But if it's off, then you can change, your firmware can change the pins and reconfigure stuff while it's running in runtime. And the FUSB IDIO pin or register, this register controls the USB ID pin on the microcontroller, and that pin is used to signal a switch from host to device mode. I only use device mode, so I configure this down the line for IO use. But if you want to use, if it's for the USB on the go, where you can switch back and forth between host and device mode, then you would turn this on. Okay, that was device configuration group 3. And we still got 3 more groups to go, and a couple of them are kind of big. So we'll push that off into the next video, and we'll call it good on this video. We covered a lot of ground. So once we get our configuration bits done, then we can write some more code and study a little bit about the oscillator probably. We'll see how much time is left in the other video, the next one. And so I think that's it, and I will see you in the next video.